keep going here. So just to review before we continue, what's new now is objective functions, right? Optimization questions. If you think of the optimal solution as like the best solution, right? Like the best scenario. And so that's what we're going to focus on. Can you add one more thing at the top here? The best solution, it's gonna be from the POIs. That's why I kept on focusing. It is actually going to end up being one of the corner points is going to be the best. That's where we're going to get it from. Okay. Okay, so we developed our system. I wrote them like side by side. We worked it all out. We ended up with our graph here, comparing the number of cars and the number of buses. Once we've graphed everything, we figured out the solution region. We had 1, 2, 3, 4, right? 4 corner points. These 2 here you could read, right? And then the other 2 we found. And remember that this one here needed to be rounded given the word problem. Only if it's a word problem. Okay, some of you round it when you're just graphing a normal, no context, no word problem. You don't need to round there. It is what it is. It's exact, right? But when it's a word problem and it's discrete data, you want to round it like this, okay? And then this is new here. See, the objective function to determine the profit would be like this. P is equal to $7.50 for every car, $25 for every bus, right? This would give you the profit you would be making if you gave it a combination, right? Like, hey, there's how many buses, there's how many cars I had. I want to give you a bunch of different options here to practice, right? What if this question had said they want the objective function, so write this down right underneath, objective function for, let's say, space available, space taken up, let's say. And instead of using capital letters, I'm actually just going to write it out. Space, right? The space that would be taken up by cars and buses. How would you write that objective function on this side? Well, we kind of already have something similar to this. Watch, I'm going to go up here. And this one here, this inequality here talked about space, right? 9 square feet, 36 square feet, 540 square feet, right? This was a restriction put on space. I'm just going to borrow these coefficients here to help me out with that objective function. So let's go down here. Space, it would be 9x plus 36y. That would be the objective function that would tell you how much space has been taken up by the combination of cars and buses. Okay, let's do another one. Objective function for number of vehicles. On page 57, right? Objective function for number of vehicles. What if it said, hey, write the objective function that would tell us the number of vehicles that are there? I will call this V, or you could actually write out, I'm okay with that. Vehicles would be, how would you figure that out? It's just X plus Y, that's it, right? That would be the number of vehicles that would be determined there. So you're like, what's the objective function again, Mr. Dirks? I'm kind of confused. It's Monday morning. I don't even know where I am right now. I think I'm in math class, right? If you're thinking like that, the objective function is simply that. It's a function that you just read. What are you writing the objective function for? We started out with profit. That's what the question asked you for. And we were given how much it costs for each car and bus. If they said, hey, write the objective function that would tell you how much space has been used up, we use the square footage, right, of each. If it's vehicles, it's just x plus y. So get used to just read the question carefully, but this one is never graphed, guys. This is not being graphed, but we want the combination. This is now the last step, right? Combination that would maximize, right? This is what it's maximize profit. And notice this word right here, maximize. It's not saying, hey, give me a possible solution. It's like, I want a solution that would give me the absolute most income right now as the parking lot owner or manager, right? How could I maximize my profit? And let's go back one step. Profit, this objective function right here would allow me to figure that out. This one right here. So watch what I'm going to do. I'm going to take profit and I'm going to go 750. And because of space here, I'm going to run through these points of POIs here. I'm going to plug them in one by one. So it's 10, and that's equal to a number. Then it's 750. The other corner point is 45, 0. There's no point in plugging in 0 to this objective function, right? So I'm just going to go 45, and that is going to give us a profit. The next is 750, and I go up here, and it's 40 cars, and 25 times 5 buses, right? It says 5 up here. We get a dollar amount. And the last one, 750. Watch this. I don't plug in the decimal here. I plug in the rounded. So 1013, I'm going to plug in this time. And you're going to get a dollar amount. So the combination that gives me the highest dollar amount is going to be the best one, right? So you grab your calculator. You can actually do this in one shot, right? You go 750 times 10, that we know it's 75, right? 75 bucks in that scenario. 750 times 45, the second line here, that's 337.50. Then it's 7.5 times 40 plus 25 times 5. You can type that in one shot like this. Okay, 425 plus, I know that this is 75 here, I know that already, plus 25 times 13, that's 825. Okay, now be careful, because the question could have said which combo can minimize the profit. You wouldn't want to know that one in reality, right? But it could ask that. So this maximizes, right? Maximizes profit right here. Right? That's a very, very important one to us. I'm going to highlight that one. Okay. Maximizes profit. So having 10 cars and 13 buses would maximize the profit. Okay. Having 10 cars and 13 buses maximizes. I will zoom into that. Let me zoom into that part. I will tell you this, there will be at least one question that will ask you to find the optimal solution, right? And that's just simply taking your POIs, plugging them into your objective function, and then figuring out which one of those gives you the greatest value in this case. Okay. Yeah. Is it wrong? Something seemed wrong about that one. Ryan, did you know all along? Maybe? Hold on. So that's 75 plus. Oh, I see what I did. That creeped in there, the answer. Sorry, guys. Thank you. Yikes. Anyway, so this is 400. So which one maximizes? Maybe this is a good teaching moment here to not make a mistake. This maximizes. Please change that. So I need to change my statement, right? 40 cars and 5 buses. My bad. 40 cars and 5 buses will maximize profit. Okay. I was just checking to see if you were awake. Gianna is awake, so perfect. So what do we do with that highlighter there? I don't know what to do with it, guys. So just make sure this is the one. Maybe this is the highlight of your day. Me getting it wrong. But that is what it is. It's 425. It's cabin life, guys. Get all the noises. Some cattle every once in a while, deer. Question. I could technically give you this exact same problem, right? But I could say, hey, give me the combination that would minimize the space taken up by the vehicles. Minimize what? Space. You would still use the same POIs, but you would, in this case, want to use that objective function and plug in cars and buses and then figure out the one that would use up the least amount of space, the smallest number, right? You would be after the smallest number. So just be careful with that. What am I asking? In this case, we use this one, okay? We use that one as our objective function. And what we did is we plugged in the POIs, right? Go into the objective function as many times as you need to until you find the right answer, the answer you want, right? Yes, hi. Page 59, I want you to first read it. I want you to come up with your variables, implicit constraint, come up with the inequalities. Don't find the intercepts or anything like that just yet. Just come up with the first 3. It's the most challenging. Once you're done with that, you go to page 60. You go to page 60. You do the same thing. Don't solve anything. I will do that with you. I will guide you a little bit, right? I'm just curious, can you write out the inequalities by reading these questions? So page 59 and 60, take a moment and read, see what is asked of you to do and come up with the inequality. Go to page 59 with me. Appreciate you trying, okay? That's half the battle, is being willing to try, and even if you might make a mistake, follow through, continue with your steps, right? So I'm going to grab my highlighter and just highlight any places where an inequality is referenced. Okay. Eliza owns a small business selling pizzas. She knows that the most popular toppings are cheese and pepperoni. According to the feedback from her customers, she knows that a good pizza has to have at least, there's that at least, right? At least 2 times as much cheese compared to pepperoni. That is an inequality right there. I'm going to highlight a different one with a different color. On average, a pizza has no more than 750 grams of cheese. So there is another inequality there. And I need another one. Pink here. And 250 grams of pepperoni. Okay. There are your 3 inequalities, guys. And you might be tempted to combine these 2, but if they speak specifically to cheese and pepperoni, separate them. Don't try to combine them. It will say combined, right? So let's come up with A, which has a lot of components to it. But X and Y, what will they be? I think all of you would agree that it's cheese and pepperoni, right? I think you would have to agree with that. I don't know if you noticed it. But what are the units in? What is it? Cheese what? Number of cheese? Grams of cheese? Yeah, it's grams of cheese. So you can do that just as long as you tell me. If you went grams of cheese, that's fine, but right, we know that these are the units. Okay, perfect. Then we have that both of them obviously cannot be negative, right? So that's your implicit constraint. You got that figured out. Constraints, so that would be it. Inequalities, let's figure that out. The first one, let's put them side by side like this, right? One after the other. There's something comparing cheese and pepperoni. And it doesn't really matter how you do this. Just I put XY or YX, something like that. And it says that you want at least 2 times as much cheese compared to pepperoni, right? So cheese is X. So that means that you want it to look like this, right? You want there to be more cheese than pepperoni, correct? So if you have that, then you're closer, and it says twice as much, 2 times as much. So where would you put the 2? And the answer is it's counterintuitive. You would want to put the 2 in front of the cheese, right? But you should put it in front of the pepperoni. Because, right, whatever pepperoni you're putting on, make sure that you put twice as much or more to get your amount of cheese. Right? And it is counterintuitive, but so I will put the 2 times, put an arrow like that. Okay, so what do we do with that? Well, we'll come up with it in a bit. Then we talk about cheese. Cheese has to be no more than 750 grams. And pepperoni, no more than 250 grams. So those are actually fairly easy ones to graph. There's no intercepts, nothing like that you need to figure out. Okay, this one, we know that one of the points is going to be 0, 0, right? There's no constant. You could rewrite it if you wanted to, right? And that we're going to do that. Let's go like this. 2y is less than or equal to x, right? Divide both sides by 2. Y is less than or equal to, we can just go 1/2 x. We're used to that, right? This is a solid line. True region is below. We will shade above. Let's figure that out first, and then we'll come up with the second point. Okay. This one is solid. True region is to the left. We will shade to the right. solid true region is below because of this, shade above. So we've got all of that figured out, where to shade, and we just need an extra point for this one. What should we let x equal to in this scenario? What would be a smart number to pick for x? Look at the other numbers, they're in the hundreds, right? So can we let x be 200? I think that's a pretty good one. Like if you let x be 200, then y will be 1/2 times 200. And what's half of 200? It's 100, right? You could have picked 400 if you wanted to. It doesn't really matter. But don't pick 2, right? It's a little bit too small compared to the rest because you want the reference. So the second point is therefore 200, 100. Okay. Don't be scared. You could technically apply this method to any of the other ones, but I find that I just leave this method to when you don't have a y-intercept that isn't 0, right? Let x be something, so it's 200, 100 because we did this. And let's graph this. Grab your ruler. I think I'm going to give you some time to graph it because I want you to practice. I'm not even going to give you a scale, nothing like that. Don't be scared to make a mistake. If you make a mistake here, the page before this is blank. I don't know if you've noticed that. We will go over there. Like you will make your new edited version there if you need to, right? So I want you to take this, graph it, see what you get, find the corner points as well, okay? I don't want to just rush through it because here. When I go through this, maybe it's a good idea, right? Like this is point 1. You know how we usually have our x-intercepts, our y-intercepts? So this is point number 1. And what we did here is to come up with point number 2. So you connect these 2 points to graph this line. Right? It should start here and then 200, 100, right? Your next thought, and then it's okay. If you don't mind, I'll just do this quietly here. My x-axis is going to go higher, right? Because I need to account for the 750 there. My y has a different scale. You notice that, right? Oh, 750. Sorry about that. that's what it should look like when you're all said and done. The POIs would be 0, 0. It would be 750, 0. You can read this one off the graph. This one you can read. This one technically you can read as well, right? This is 750, 250. Notice that it's grams, so technically decimals are okay, right? And so you need to find this one using your calculator. You just leave that diagonal and the horizontal, and I get 500 to 50. Is that what you got? And so you're very close now, right, to the end. And so if cheese is, allow me to just go up to B here. If cheese costs 65 cents per 100 grams and pepperoni is 85 cents per 100 grams, determine the objective function, right? So we'll do that, but there's a little bit of a trick here. And you know that my examples are not always like smooth, straightforward. There's always a bit of a catch there. But the objective function, you have to make sure you understand this. It's 65 cents per 100 grams. If you divide that, you actually get 0.0065 whatever per gram. That is for cheese. And pepperoni costs a little bit more, 100 grams, because it doesn't, our variables are per gram. So you don't want to have the 100 gram there, right? So that'd be 0.0085 per gram. And that's in dollars, right? Even though it's a very small amount, we'll keep it like that. Okay. So the objective function for cost, how about we just call it cost? That's fine. You can call it C if you want. It would be 0.0065x plus 0.0085y. This is what you would usually get a full mark on a test or AC for just writing out that objective function. Just writing out that objective. If it said, hey, write down the objective function that would give us the amount of like the grams used, right? You just go x plus y. But it's never graphed. The objective function is not graphed. You grab your POIs from the graph and then insert them here. So let's go ahead and do that. So 0, 0 is really irrelevant. I'm just going to go, right? If you plug in 0, 0 here, it's 0. And then you go 750, 0, so that's 0.0065. I want you to at least show me the step where you plugging it in, right? And then the next one is 750, 250. And the last one is 500, 250, right? So 500, 250. So there you're, obviously the 0, 0 we're going to omit, okay? Because you want to make money, right, as a business. So not using any would not really be feasible, right? So omit that one. So we go 750 times, this gives you 488, right? This here, 750 and 250 gives you $7 if you plug that in. If you plug in 500 and 250, that gives you 538. And we want to minimize cost, so this will minimize cost. And you know what? I think I'm okay there if you just leave it at that. you could say using only 750 grams of cheese will minimize costs, right? So it depends on the scenario. If they wanted to maximize profits, obviously they would have to give you some kind of way to make profit. They would have to mention those numbers. It doesn't, right? So that is the best answer here, 750, right? Using only 750 grams of cheese. Okay. Okay, we're going to do one more. I don't know if you already wrote the inequalities. I will just tell you how we're going to end the day, okay? I'm going to give you the ones that I want you to practice after. So let's flip over to page 60. This one I'm going to get you started right now. I'm going to help you write the inequalities and you do the rest. You need to make it all the way to the objective function and finding the best solution. And at the top of this, I'm going to ask you to do, this is going to be your homework, page, let me just flip, I just need to make sure I get the page numbers right because this booklet is different than my original. So 63, 64, 65. Page 63 to 65. There's three optimization questions. You can do, if you feel like you do two, right? I've done two. I think I've got it, Mr. Dirksen. I take it from here. Sure, but just not doing it. I don't recommend that. I do not recommend just, it's like, I kind of get it. I'm just going to wing it. You're going to run out of time on the test if you don't know exactly what needs to be done, right? So let's see this backside here. Okay, what I'm going to do is I'm going to freeze it here. I call it job A, job B, but it's really pumping gas call center, right? Those are my hours at both. Can't have negatives, of course. And notice that I say that continuous data, right? Meaning you don't need to round your POIs. And so this tells you that, right, the hours have to be combined less than 45, less than or equal to 45. You want to make at least 345 bucks, right? So you make 1250 at the first job, 1425, so it's all dollars amount. I don't know if you want to write at the top, right, max 45 hours. This takes care of that, right? At least 345 bucks that you want to make. This inequality takes care of that. Less than 20 hours at job B, okay? That takes care of that. You notice the inequality symbol? Something special about it? It's less than, right? It's not up to. So I'll tell you what, don't worry about the POIs, right? Like if it's landing on that line, we still consider it, right? I just wanted to throw it in there for you to see that it could happen, but I can guarantee you that on the test, it's not going to be the case. I'm not going to make you have to decide between dashed or solid when it's a word problem, okay? So you take it from here. I want you to graph these. There's no special case. Remember the one we just did before this where you have to get the origin and then a second point. You don't have that, so you don't need to worry about that. But graph it, solution region, all of that. I wonder if I should give you I'll just scan and post the answer if I run out of time. We have over 15 minutes. You should be able to get this done in 15. So there you go. Take it from here. You're great. You're always trying. You're not just sitting there. It's like I just won't get it, Mr. Dixon. You can try your best. It just won't happen, right? You don't want to go there. That's a bad path to end up. Just be like, you know what? I'm going to give you my best, Mr. Dirksen. You figure it out from there, right? If you can do that, you're good. Yeah, your graph should look something like this. I don't know if I'm going to scan. I think it's just going to be here. So if you need to look at it, just look at the video. The objective function, which is what you need to come up with, is we're using similar. It's a similar form than the inequality up there, except for we don't care about the inequality, right? We just want to know, hey, this objective function would give me the income if I gave it the combination. And some of you might be wondering, Mr. Dixon, what about the dashed line? I thought those POIs are not part of the solution. It gets too complicated with a word problem, so we're just going to take them. The solution would be to just go slightly under the 20, right? But we're not going to worry about that. I'm not going to give you a dashed line on word problems normally. So have a good one, guys. I will give you an AC on objective functions tomorrow, right? So be ready for that. Have a good one.